All right, welcome everybody. The Office of Programs to Enhance the Neuroscience Workforce within the National Institute of Neurological Disorders and Stroke is very pleased to welcome you to this open stage webinar series. This is a targeted outreach effort that we have for our diverse neuroscience community to learn about NINDS programs and meet the amazing people that are funded by NINDS, that work with NINDS staff, and so on. So this month, we're really excited to talk all about team science. Before we get started, I just have a few housekeeping items. We go to the next slide. So a few meeting reminders. All attendees are muted. You won't be able to turn your cameras on, but you are very welcome to post any questions that you have throughout the webinar in the Q&A box. If you have like a general comment, feel free to use the chat, or if you want to DM the hosts and panelists any specific concerns. You can also upvote questions in the Q&A box, and we'll kind of ask them throughout. You can also enable closed captioning under live transcript at the bottom of your screen. And a reminder that this meeting is being recorded and will be transcribed and archived on our website. We will send you so much information after the webinar is over. We'll send you the recording, a lot of resources, any slides that we share afterwards. So check your inboxes probably a week or two after this event ends for that. And then please do stay connected with us. Feel free to email us if you have any questions about this webinar series. So with that, I'm very excited to pass it off to our NINDS Program Officer, Cory Kelly, to get us started.
Thank you, Anna, and thank you everyone for joining us today. My name is Cory Kelly. I'm a program officer here at NINDS and serve as the advisor for research operations and program implementation, and I'll be your moderator for today's discussion. We've comprised an excellent panel that I'll introduce shortly that brings a wealth of experience, knowledge, and diverse perspectives towards integrating team science into the early career stage scientist experience. As you may know, team science is a relatively nascent field where we're only just beginning to establish best practices. So as this conversation evolves, we're now very much focused on how we can more effectively engage and train the next generation of team scientists, and thus the focus of our conversation today as we continue to build this community of practice. So I'm just going to provide some brief context for those that are new to the team science field, and then we'll get right into introductions and the conversations. If you'd like to reach me or my program Karen David, who I'll introduce shortly, you can contact us at NINDSteamscience@nih.gov. Next slide. Okay, so what is team science? Team science approach involves two or more individuals working interdependently towards a shared scientific goal. And the shared scientific goal is really what grounds a team together. And teams can be various sizes, they can be comprised of various disciplines, and they can have various levels of integration. But the reason that we engage in team science is it expands our ability to pursue challenging problems in neuroscience research in a comprehensive, interdisciplinary, rigorous, and mechanistic manner. And as I mentioned, although team science is a growing new field, we have identified some lessons learned, facilitators and barriers to team science. Facilitators to team science include beneficial attitudes and beliefs, effective team processes, brokering and bridge building activities, and funding initiative characteristics, which you'll hear more about from our panelists today. Some of the barriers also include integrating diverse teams, discipline-based differences, project management complexities, and the incentive and reward system. As Anna mentioned, we will send out some resources. I have some of these on the slides that you can refer to in the future. On your right, on the slide, we have the Collaboration Team Science Field Guide, as well as Enhancing the Effectiveness of Team Science, which is considered the foundational text in team science. It was released in 2015 by the National Academy. And I'm going to talk a little bit more about this on the next slide. But if you are getting started in team science, that's the book you want to go to. Diverse perspectives are critical to team science. They allow us to address bias and make more generalizable results. And we believe in a community-based participatory research process where you engage with your participants in the design, implementation, and evaluation of your interventions, and this creates more sustainable results. Of course, you'll need to identify the correct diverse perspectives and make sure that you have adequate capacity in those diverse perspectives. And as you're bringing them together, you need to think prospectively about the integration, how to create common ground and how to manage conflict, as well as how to communicate change. If you're interested in engaging, thinking about integration, I encourage you to read Interdisciplinary Research by Repko and Stozek that really talks about how you can bring together and converge these diverse perspectives. So as we think more towards early career scientists, kind of the rationale is a number of publications have come out the last 10 years from the National Academy, from the NIH, from the National Research Council, and even from NINDS. And as you may know or have experienced yourself, fewer and fewer early career stage scientists are going into the traditional faculty PI role. And this has really resulted in a mismatch in how we're training our scientists with the real skills that they'll need once they arrive in their terminal careers. And team science is often the elements of team science, communication, project management, these so-called soft skills or social sciences are often the top identified skills that both employers and early career scientists say that they're missing when they complete their education. Beyond that, as an early career scientist, there is benefits and negative effects of engaging in team science, and you have to balance those, particularly as you're an early career stage scientist trying to establish your career. There is an important value in individual recognition, which can sometimes be in conflict with the needs of collaboration in team science. So it's really can be a challenge as an early career scientist, if you believe in team science, to still engage in these and get your individual recognition you need to establish your career. So what are we doing about this? Well, first, we're having conversations. We're building a community practice. That's the point of today's call. You'll recall I did mention this foundational text, Enhancing the Effectiveness of Team Science, that was released in 2015. My program colleague, Cory, who's on the call, and myself are on the new National Academies Committee to release a revised version of this in 2025. And one of the topics that we're revising and focusing on is early career perspectives. You'll see on the screen, we just had a call 2 weeks ago where the committee brought in a number of early career scientists to provide their perspectives on engaging with team science and what the barriers and facilitators and how we can improve this in the future. So this is a very active topic, and we thank you all for being here today to participate in it. Last, I just have to give a plug. On December 12th, we're holding our second NIH-NINDS Team Science Series. This will focus on convergence in complex science. So if you really want to understand and hear perspectives on how you can bring together diverse perspectives and integrate them into a singular force to achieve transformative science that really matters and has effects in the real world, then I encourage you to register, and we'll go ahead and drop the links in the chat. So with that all being said, I will stop sharing and introduce you to our wonderful panel. So first, we have Farah Bader, who is a health program specialist with the Brain Initiative in NINDS. We have Hermon Gebrehiwet, who is also a scientific program manager with Brains Initiative in NINDS. Gnadt, a program director with the Brain Initiative and NINDS, and Karen David, a program director with the Brain Initiative and NINDS. And as I mentioned, she's also the co-lead on the NINDS Combine, or our flagship team science program, along with me. Our early career scientists that were kind enough to join us today, we have Ashley Abel, a PhD candidate at Yale University. We have Dina Popova, a research scientist at NYU Langone Medical School and Neuroscientist Institute. Mariela Petkova, a postdoctoral fellow at Harvard University, and Nancy Damrah, who is both a PhD candidate at George Washington University, as well as a full-time professor and practicing clinician in occupational therapy and neurorehab. So interesting perspective there. So with that being said, I think we can go ahead and get into the conversation. Yeah, thank you. And I'm going to drop the profiles in the chat. You can learn more about us, contact us. We're happy to talk with anyone. So maybe, Farah, we can start with you, and you can tell us a bit about what inspired you to pursue a career in science, and how did you navigate to your current role?
So I have always been fascinated by the mysteries of the brain, and so that made me naturally gravitate towards cognitive neuroscience and psychology, which is my background, alongside of global public health. As Cory mentioned, my current role is of a Brain Initiative Health Program Specialist and also as a trainee coordinator for our team science programs. So I was introduced to team science through my work at Fogarty International Center, which is another NIHIC that funds global health research and focuses on research and research training capacity building efforts. Since international partnerships are by nature very collaborative and involve different disciplines with scientists in varying geographical, cultural, and professional contexts, the experiences I gained from these 6 years in program management at Fogarty taught transferable skills for this position and made me realize the value of multidisciplinary research and how it gives you insights on scientific questions that you wouldn't normally obtain with only niche approaches.
Thank you, Farah. I really look forward to hearing more about the international work that you've done. Hermon, maybe we could throw the same question to you as well. What inspired you to pursue a career in science, and how did you navigate to your current role?
Sure, yeah. So my background is in public health with concentration in epidemiology. I think I've always been interested in public health, and then um I got into 13 years experience in clinical trial management. My current role is a scientific program manager. I coordinate trainee or early career scientist activities for brain research opportunities in human. Um, I also facilitate trainee activities for U19 during site visits. I was introduced to team science through my work in clinical trial management. Um, as a clinical trial management, the position involves coordinating activities between different stakeholders, such as sponsors, regulatory bodies, and clinical sites to ensure the trial adheres to protocol timelines and regulatory requirements. So, from a team science perspective, the success of any clinical trial involves effective collaboration and coordination between various stakeholders and collaborative efforts across diverse disciplines to achieve the trial's objective. So, I think my work as a clinical trial management kind of opened the door to my current position.
Thank you, Hermon. I too came from a clinical background, and certainly it takes a village to run a clinical trial, as they say. All right, Jim, maybe we can go to you. You want to tell us a little bit about your background and how you came to your current role?
Okay, yes, thank you, Cory. So my background is in systems and computational neuroscience. I spent more than 25 years in an academic position doing academic research, but then for the last 14 years, I've been an NINDS program director, and 10 years of that has been as a brain co-lead for the systems and computational neuroscience. As a team of NIH program directors across multiple ICs, the neuro ICs, we had the opportunity to design novel funding mechanisms, including programs and collective teams of research that cross multiple disciplines to address questions at a large scale. Our brain team research programs have transformed the way investigative neuroscience can be done, and it's created a rich environment for early career scientists to flourish in a team research setting.
Thank you, Jim. Thank you. And Karen, you've worked on a lot of these programs with Jim. Maybe you could also tell us about your background and how you got to your current position.
Sure, thanks, Cory. So my career has been very multidisciplinary because I was driven by my broad curiosity of different topic areas. So I was trained in molecular and cellular biology with a translational bent during my time as a PhD and a postdoc fellow, then pivoted to more basic and systems neuroscience topics during my time at NINDS and with the Brain Initiative. So I was exposed to a wide breadth of topics and approaches, and this shaped my appreciation and interest in the type of questions that we could ask that rely on the integration and synergy across different disciplines. So now as a program director for Brain and NINDS, I feel very lucky to be able to support different scales of team science. And today, together with my colleagues, we hope to share with you our experience as a funder in promoting and optimizing collaborations across diverse areas of science.
Thanks, Karen. Maybe you could just tell us a little bit more about how your role at NIH supports team science for early career stage scientists.
Thanks, Cory. So I'll just start by mentioning that team science is just one type of funding at NIH. And here, our goal is to balance support across different stages and scales of projects. But in this conversation, we chose to highlight team science because of its potential for a transformative impact as well as the challenges associated with team science, given that our incentive structure remains focused on the individual. So I'd like to highlight 2 ways by which we are able to make sure that the voice of early career stage scientists is heard and represented. So one is through the BRAIN initiative. So BRAIN pioneered the inclusion of a plan for enhancing diverse perspectives in all of our funding opportunities with BRAIN. And this is because we believe in the power of diverse perspectives and enhancing the merit of the science. So I recommend checking out our BRAIN website to learn more about this. And second, we regularly meet with our trainees during our site visits to learn from their experience. So Farah will talk more about this. But overall, we are seeing an increase in the number of multifaceted trainees as a positive outcome of these transdisciplinary environments that we're supporting.
Thank you, Karen. Yeah, I know, a really big focus of ours at NINDS is focusing on training interdisciplinary scientists in the next generation. The BRAIN Initiative has gone a long way towards this, and we're continuing it with the Combine program. You had mentioned that one of the things Farah does is trainees in site visits. Farah, I was wondering if you could maybe talk a little bit more about your role in supporting the U19 trainees.
Absolutely. As an early science coordinator for our team science program, my role is to serve as a resource. As Karen mentioned, we co-lead these early career scientists lunchtime listening sessions at our annual Team Science U19 site visits. And we facilitate the conversation among the early career scientists, document any sort of challenges and concerns that they have raised about conducting research. And then we also praise the practices that are working in the research labs. In addition to funneling the feedback from the early career scientists back to the PIs and the mentors, we also take notes of topics that are raised in order to continually improve the program itself, and on a broader scale to utilize the knowledge that we have gained to delve deeper into important teaming related issues. These sessions have inspired the creation of a U19 Early Career Scientists Outcome Working Group with representation from a lot of early career scientists and program administrators from most of our U19 grant programs, and also a few select NIH program officers at different ICs that are involved with the BRAIN Initiative and involved in training and fellowships.
Thank you, Farah. I think, I really love to hear that you're creating this dialogical environment. We talk a lot on our Combine program about how PIs can create environments that are conducive to team science, particularly for trainees. And I think one of the best ways to do that is kind of flip the script and have your lab meetings or your interactions be dialogical, where you're having conversations rather than, just dictating tasks or direction to people. So I really love to hear that you have that back and forth conversation, because I think that's a key tenet of team science, particularly for early career scientists to feel comfortable engaging. I know you're working on the BRAIN U19 program, Farah. I think, Hermon, you're working on the BRAIN ROH program as well. Maybe you could tell us a little bit how you're supporting early career scientists through that program.
Sure. Thanks, Cory. So I work both in the U19 and the ROH consortiums. I serve as an operation manager for both consortium activities, and I also coordinate U19 annual site visit logistical aspect of it. So to support the early stage scientists, one of the things that we do is encourage the PIs to give them a presenter role during the site visits. We also ensure, as Farah and Karen mentioned, that one of the agenda items is designated time for private discussions between the early stage scientists, EABs, and program staff. In a virtual setting, we create breakout rooms for safe and open discussions to happen. And so once all these discussions happen, the summary is anonymized and included in the site visit report for the PIs and the leadership of the U19s to address for the next funding year. In terms of the ROH consortium, my colleague and I, which I will mention, Dr. Saber, she and I created Junior Investigator in Human Intracranial Neuroscience Seminar Series. The members of this groups are early career scientists, and they're elected by the PIs And so we coordinate these seminar series based on their interest.
Hermon, yeah, I love that you kind of hit two different critical aspects of communication. Is one is, establishing environments for effective and safe communications. And the other one is just like we're doing today, building a community of practice and allowing, other people to network with each other and create, relationships and solve shared problems and create shared solutions. So I love that. Thank you. Jim, we'll throw it to you. Anything else to add about how we're supporting early career scientists here at NIH and NINDS?
Well, especially for early career scientists, the collective team research approach has both advantages and it has disadvantages. So the advantages include multi-mentored exposure to multidisciplined approaches and involvement in really large-scale, large-impact research. But there are some challenges, for example, credit assignment for each individual's efforts and navigating complex scientific and interpersonal priorities. But we're encouraged that rather slowly, but coming along, that academic culture is coming to grips with how to recognize the contributions of collective research efforts. And what better preparation for various non-academic careers than broad involvement in investigative research endeavors?
Yeah, thank you, Jim. I mean, you're completely right about, cross-disciplinary training and mentorship is one of the huge advantages of team science, particularly for early career scientists, not only in preparing them to do, interdisciplinary scientific research, but prepared to work with diverse perspectives and diverse opinions and how to work on teams of very, various composition. Jim, I might wonder if I can just follow up to you. You are one of the senior program officers on the call here, and I was wondering if maybe you could just talk a little bit, you and Karen perhaps, about how team science has evolved at NINDS and how we kind of take up our program development philosophy towards that.
Okay, yeah, sure. Thanks, Cory. The dedicated funding appropriations of the BRAIN Initiative gave us the opportunity to experiment, among other things, on how to support collective team research efforts at a scale larger than the traditional NIH R01 awards. And when we started this in 2014, there were few examples of team research models in neuroscience. And we had questions about what is large enough to accomplish the big research questions at scale, and what is so large that it loses its financial investigative efficiency. We thought about how to balance collective consistency with individual creativity. And starting about the same time, there were several other team research programs that were starting up. Some were large scale, like the European Brain Program, the Brain Initiative Cell Census Network, along with the Allen Brain Institute. And then there are these medium scale efforts, such as the International Brain Lab, the NIMH Conte Centers, and our Brain Initiative's Team Brain Circuits programs. Our brain programs have emphasized a coalition around investigator-initiated research questions and that are peer-reviewed for merit. We're pleased that the Team BCP program has found a sweet spot for selecting high-impact research by the most qualified research teams, usually of 3 to 5 international labs that can be internationally involved. That balance of intellectual creativity with the wisdom of collective team research approaches is very helpful. There are now examples of similar organizations and similar scale of cell biological research at NIGMS and at neurological research at NINDS. And I think Karen can talk a bit more about that.
Yeah, go ahead, Karen.
Yeah. So I'd like to talk about how we created our new team science program at NINDS, because we were driven by this question. As a funder, is there a way we can design our funding programs that will set these teams up for success, right? So how do we go about answering this question? So we collected information in 3 ways. So first, we paid attention to what's out there already. We learned from the experience of other funders. We've looked at existing designs of team science funding opportunities and outcomes. And Jim mentioned several examples of this. So that's one. And second, we also learn from the experience of the PIs of the teams we currently support. So through our annual site visits with our brain teams, we found that the hardest part in collaborations is true integration and synergy of efforts across labs. because a default way for PIs at the moment is to operate in silos, right? So we took that into account, and a structure informs function in our NINDS Team Science program. We want to emphasize integration, right? So the way we did that is we deviated from your typical multiple component structure of team science, where you have multiple projects with cores in one program. And we changed that to just one focus goal or aim in the RM1 combined program. And as Cory said, it is this goal that grounds and glues the teams together, right? So third and lastly, we paid attention to insights from this emerging field of the science of team science, as well as the studies from the National Academy, which Cory highlighted. So we noted common barriers in team science, and we built our design of the RM1 combined program to plan around this and brainstorm potential solutions and be thoughtful about this in anticipation of a team science effort. And in addition to this, we're also working to increase awareness of lessons learned. Could be experiential, could be theoretical, by bringing in speakers from the field of science of team science to our meetings with our funded teams, as well as the broader NINDS and BRAIN community. So we'd like to keep building on our community of practice here, as Cory said, within NIH, and eventually broader to include our key stakeholders. So overall, the main theme here is we'd like to keep learning about challenges and potential solutions and build that in, those lessons learned, into the design of our programs, and then disseminate this information to the broader community.
Thank you, Kara. Yes. Hermon and Farah, you have taken a lot of this foundational work that Karen and Jim have done, and have now taken that and started implementing it into practice. So I was wondering if maybe, Hermon, you could first just tell us about some of the activities that you're conducting in these programs to support the early career stage scientists.
Yeah, sure. So for the ROH, or Research Opportunities in Human Neuroscience program, as I mentioned, my colleague and I, Dr. Sabri from NIDCD, created a junior investigators in human intracranial neuroscience group. So the core group is about 48 members from labs across the ROH consortium. These are early career scientist groups that form to facilitate lateral information sharing and career networking. So we organize this by collecting early career stage scientists contact information from the ROH PIs. And then to make it easier for centralized collaboration, we created Team Channel and SharePoint site. And once we assemble all of them, we had a meeting, and then they decided to have a bi-monthly seminar series, starting with introductory sessions where members presented their work and they introduced each other. So they also elected 2 members to run the meetings on a rotating basis, and to kind of ensure everybody gets a leadership opportunity, we made it a rotating base. We also deployed a survey to prioritize topics of interest that will guide the selection of seminar speakers. So one of the lessons learned is that once you provide this type of platform, it facilitates networking between members who would not have otherwise met outside of the larger group. The early career stage scientists, we found out that they organically organize based on their interests into subgroups, and we've actually learned that some of them actually met at conferences.
Yeah, thank you, Ron. Yeah, I think, giving people opportunities to shine is a really good approach to early career stage training and PM science. And I love that you mentioned creating this, collaboration space for everyone. As Karen and I both mentioned, this upcoming 2025 revision of Enhancing Effectiveness of Team Science, one of the other primary topic is conducting team science in the virtual world. So it's definitely something we're looking at as well. Okay, Farah, maybe I can finish up with you before we move on to our early career stage panel. Very excited to have Farah share some work that her and myself and Dina, one of our other panelists, worked on the U19 program, if you don't mind, Farah.
So From our U19 Early Career Scientists Outcome Working Group that we referred to earlier, we organized a smaller group of just 4 volunteers, of which 3 of us are here, including Dina and Cory. So these volunteers really took this at the helm and carried out a Delphi process by collating topics that impact ability for early career scientists to navigate collaborative research. They started with an initial brainstorming session with the wider, larger working group, and then conducted extensive outreach and recruitment to the broader ecosystem of early career scientists, and then also developed and deployed a questionnaire. The goal was to build consensus around what were the most critical topics, and the data from the Delphi was analyzed and presented actually at a recent internal consortium meeting in June, and it's now currently being written up to inform, improve, and optimize early career research trajectories with an eye towards tailoring this document according to career stage and duration of time in collaborative research.
Yeah, thank you, Farah. I think it's maybe perhaps a selfish plug to kind of talk about, theory to practice. And I talked earlier in my slides about a community participatory based research approach. And this is a great example of that, where we actually went out and had conversations and obtained information from the early career stage scientists so they could tell us what they needed and we could develop best practices with them. So yeah, thank you, Farah, and thank you, Dina, and we'll hear more about that as well, I'm sure. So thank you to my NIH staff panelists. We'll go ahead and flip over to our early career stage panel. Again, anybody can feel welcome to jump in at any time. So we'll just back to the original question, and we'll go ahead and start with Ashley. Ashley, if you could just tell us briefly about what inspired you to pursue a career in science and how did you navigate your current role?
Yeah, absolutely. Thank you so much for having me here. So I'm entering the final year of my PhD at Yale, and my career in science goes back to my undergraduate experience in Seattle. I was very fortunate to have some fantastic research opportunities that involved team science very early on, one of those being a collaborative project between the Department of Neurological Surgery at University of Washington Medicine and the Department of Bioengineering. It was a really exciting project modeling patient-specific aneurysm morphologies with bioprinting, and really gave me some fabulous exposure to how diverse perspectives from very different areas, clinical versus basic science versus engineers, can work together to solve issues that have been longstanding in science for several decades and have not had this type of interdisciplinary lens. And that has really driven me through my career now to places where I am constantly beginning collaborations between more clinical scientists, whether MD, PhDs in my lab, with my own basic science training, or theoretical physicists across different countries, working with my skill set in developmental biology. And it's been very enriching, so I was quite fortunate to have that early on.
Thank you, Ashley. I mean, you bring up an interesting point that, especially when you start to get beyond neuroscience and get into different fields completely, where you're bringing in doctors and biologists and engineers and computational stuff, you really have to consider not only how those different fields are communicating, but also at some point you're probably going to have to harmonize data between those fields, and you really need to think prospectively about those interactions. Nancy, yeah, thank you, Ashley. Thank you. Nancy, you want to tell us a bit about your background and how you got to your current role?
Sure. I'm an occupational therapist by training. I practiced mainly in neurorehabilitation settings as a clinician, where my clinical reasoning pathways reflected evidence-based practice. I've always been fascinated by the creation and translation of evidence-based practice timely and effectively. And as a clinician, I saw that when I was practicing with the population of acquired brain injury with a lot of uncertainty. So my focus was to learn the art and science of generating knowledge and scientific discoveries in real-world settings and translate that into practice to solve complex problems in learning health systems pragmatically and comprehensively. So I followed a traditional academic career path by pursuing a doctorate degree in occupational therapy from Boston University. Then I transitioned after that to academia. So I had a different lens as an educator here, teaching entry-level OTs in rehabilitation while integrating evidence-based practice, interdisciplinary research in our teaching. After that, I pursued a PhD in translational health sciences and implementation science, which is my area of interest, from George Washington University, where I started building the foundation of my research career as a translational and implementation scientist. I feel I started being incorporated in team science early on as a clinician, where we used to have opportunities to practice within cross-disciplinary teams as like within my social and professional identity in interdisciplinary team. And I feel like I was fortunate to look to have a different lens as an educator, and then after that as a scholar and researcher. Thank you.
Thank you, Nancy. Yeah, I think, team science is valuable in many different contexts. I think one of the things we talk about is team science isn't always the solution, but certainly I feel like in the context of neurorehabilitation, when not only are these patients trying to overcome medical and physical limitations, but also the many multifactorial contributors to health and wellness that go beyond simple clinical diagnosis, and how can we integrate those differing perspectives to achieve holistic improvement in health, both mentally, physically, socially, etc. So yeah, I'd love to hear that. And I think you have a very interesting perspective as a practitioner and a trainee. All right, Mariella, if you could go ahead and tell us just a bit about your background and how you came to your current role.
Sure, thanks, Cory. It's really a pleasure to be here and part of this conversation. I am a postdoctoral fellow in the Lichtman and Engert labs at Harvard, and we use electron microscopy to map the connectome of the zebrafish brain. This is one of those projects which is funded by the U19 Brain Initiative. But my career actually started as a physicist who worked on early flight development as an undergraduate with Bill Bialek, Thomas Greger, and Eric Fischaus at Princeton, which was an interdisciplinary effort that brought together theory and experiment. And I think this gave me the initial start in seeing science as done by sort of all means necessary. And it's an experience that served as a foundation and a launchpad for the team science approach that is absolutely essential for doing any connectomics effort, such as mapping the whole brain of a larval zebrafish.
Yeah, thank you, Mariella. Yeah, I love that you began your work as a physicist. I think Ashley had spoken about doing some computational work, and I had done some computational work in my time, and I was trained as a biologist, and it really kind of threw me trial by fire when you're thrown into a room with physicists who really, coming from a biologist perspective, it's like a different world and a different language, and even just like how we try to figure out like just how to implement projects, let alone talking about data and scientists. Just like the way we did things was completely different. But I think, maybe I have a bias that physics is kind of fundamental to all science. So I think it's really important that we do learn how to, engage across these disciplines. Thank you. Thank you. All right. Well, Dina, if you could tell us a little bit about your background and how you came to your current role, which I think is pretty recent as well.
Yeah, thank you, Cory. I will be short. So currently, I'm a research coordinator at NYU Langone Neuroscience Institute. One of the reasons why I chose to do science was, big pause, I was sure I will not need to communicate with people. And by the way, I have no doubt that I'm not the only one like that. So only after 8 years as a postdoc and career path change did I understand how wrong my thinking about science was. And here I am now spending 90% of my time doing communication in team science settings.
Yeah, thank you, Dina. Yeah, this is something we talk about a lot, and yes, as well as as you evolve or mature through your career, you're doing a lot less bench work or patient care and a lot more people management and communications, and a lot of team science and science in general really comes down to managing projects and people and communicating effectively. I think, maybe there is an archetype where a lot of us thought, science, we could just sit there and do our work, but it turns out in this modern era, nobody's working in a silo anymore. And in a lot of cases, the biggest problems require us to engage across, different disciplines. It's been my pleasure working with you over the last 6 months as well on the U19 project. Okay, maybe if I can come back to a few people just want to follow up on a few things you mentioned. Dina, I know you've been involved in the U19 program. I was wondering if you wanted to tell us just a little bit more about your experience in team science in the U19 program or otherwise.
Yeah, so when I joined one of the Brain Initiative funded U19 group as a research coordinator in its 4th year, there was significant amount of misunderstanding within the team, and no one was really happy about the overall progress team made over the years. I was lucky enough to have experience with a large collaborative initiative before with the NIAAA as a postdoc, so I was aware of potential problems which could impede team's anticipated progress. So when I came to the group, I had something to focus on. I talked a lot with people, scientists of all levels, starting from research associates and research assistants up to the PIs. And I collected all the feedbacks I could. And it was a lot of feedback, of course, but I grouped it in 2 major categories, which is actually team structure issues. Most of the times it's absence actually, and communication difficulties. I would be happy to talk more about it, but for sake of time, I would just mention that both classes of problems are important, and majority of teams I have worked with so far, with rare exceptions, do have struggles with both.
Yeah, you raised such an excellent point. One of the things that we recommend to our teams in the Combine program, or to any team, is to prospectively create a collaboration agreement that kind of outlines how your team is going to work together and how credit and reward and recognition will work. Because if you can do this ahead of time, it's a lot easier than in the moment where you're in conflict, where people are trying to deal with the problem, and their emotions at the same time. And if you can kind of think through this prospectively and think through these problems, it makes it a lot easier in the moment. And we really encourage people to build these documented collaboration agreements. And it's really helpful as well for new staff that come in and join the collaboration, because then they have a reference document for how the team works and what the expectations are. So yeah, definitely a critical element. Mariella, you mentioned doing some connectome work in the zebrafish. I imagine that took quite a lot of people to bring together. You want to tell us a little bit about that and how team science helped you do that?
Right, Cory. I think doing connectomics is one of those projects that is impossible, absolutely impossible to accomplish without any team science. At the very least, it requires scientists with multiple expertises like neuroscientists, computer scientists, engineers, microscopists. You can't even find all of the expertises in one institution. You often have to talk to different institutions. I work with people in Google, with teams at Harvard and with Janelia, but also it creates very interesting opportunities to even reach out and do citizen science as well, and involve students, just the general population as well. I personally had my mom help me make ground truth to be used for our segmentation models.
Yeah, I think it's really interesting. I was talking to some NINDS applicants just the other day about some connectome research and fit for our Combine program, which if you're not familiar with the Combine program, the research question you're asking has to be complex enough to necessitate a team science approach. And we were asking them, like, why do you think this is a good fit for the Combine program? And they said to me, if we keep doing these individual efforts instead of just getting everybody in the same room and doing the whole connectome at once, we're never actually going to get the answers we want. We're just going to keep getting half answers. But if we can just do this all together, all at once, we can answer this question once and for all. And I think that's kind of the beauty of using team science for the right reasons. And the connectome is an example where you just can't do it any other way. And so if we do need these teams, then let's figure out how to make them as effective as possible. Oh, yeah, thank you. Nancy, you want to talk to us a little bit about your experience in team science throughout your career so far?
Sure. I think since I started my PhD, I start using the team science as like an official name, but I was practicing that before as an interdisciplinary or cross-disciplinary teams, where the collaboration and research with team from diverse scientific background, adding really excellence, innovation, problem solving for research. One of the highlighted areas that I'm working on right now is to incorporate end users in the research as collaborators, where we said like each member of the team science coming as an expert in their area, and even end users are experts in their area. So in my research right now, I am looking at the collaborative relationship between rehabilitation professionals and patients with acquired brain injury and their caregivers. And there is research collaborators as patients and their caregivers in the team, where they are experts in their experience of the acquired brain injury. So being a clinician at some time gave me that experience of end users are also experts in what they experience and are really important to be part of the research team, where their perspectives are really valuable to the team.
Thank you, Nancy, and thank you for making my slides seem correct in showing that you are engaging in community participatory-based research. And there's something that you said that really kind of struck me is you said you kind of were already doing team science, but you didn't realize it. And I think that's a case for a lot of people. Like, it's a reality. We all have to do team science. Like, I don't think any of us are probably working completely by ourselves. And I think a lot of us maybe take for granted or maybe don't even know there's a lot of resources on how to effectively team and do collaborations, and we have to do it all the time. So we're scientists, and there's evidence on how to best do this that we can rely on. And I also just want to hit one other thing is I love that on the community-based participatory research that you're bringing in patients as co-researchers or participants, and I think especially here at NINDS, if anyone is interested, we've published a lot of this in our prioritization to include patients with lived experiences in not only as participants, but as co-researchers in the design and the implementation and the evaluation of the programs we're doing. So I love to hear that you're already out in the community doing that. And I think that's something that we really value here at NINDS and want to see continue. So thank you. All right, Ashley, I'll come to you last. I know you mentioned you did a lot of biology and engineering and computational work. Maybe you could tell us about that or some other team science work you've done so far.
Yeah, absolutely. I'd love to highlight a more recent example in graduate school where, building off of Nancy's example, I've now transitioned after doing more neuroscience research as an undergraduate, more looking at women's reproductive health and early pregnancy, first steps of human development. And this space, as many of you may know, is extremely understudied, and it's very exciting to see the attention on it now. But it is probably the most interdisciplinary work that I've been doing as a basic scientist in the lab, focusing on building new model systems, but also speaking with clinicians who have interacted with patients with this range, these huge range of diseases that are quite understudied, but kind of as a third player here that is also important and informs the research and informs the future directions, the patients and the community groups that are experiencing these. I was just on a different NIH roundtable yesterday for endometriosis, and hearing some of the patients' lived experiences is hugely valuable. And that's part of the key too of understanding what needs to change, what we need to be targeting in our research, and how we can think about it creatively in an area where the liver really hasn't moved in decades. And so I think that it's a beautiful example of how team science can be a very powerful way to bring us forward. And it's quite exciting for me at this early stage in my career to have a small part of that.
Thank you, Ashley. I mean, we're certainly laggard on our women's health research, and I'm glad that this has become a focus of the NIH. And of course, President Biden signed an executive order earlier this year to advance women's health research and innovation. So I'm glad to see that's already boots on the ground. And that, I mean, sometimes I feel like it goes without saying, but like historically, women were left out of research on women's health, and fundamentally that's of course wrong. But now again, it goes without saying, but it's like so critical that we include all these diverse perspectives in how we develop research and innovation towards the people that it belongs to. So I really appreciate you doing that work, and it's a big focus of us at the NIH right now as well. Okay, let's see. So as we're thinking about engaging the next generation in team science, what if maybe you could tell us one of two things or both? What have you experienced in your career that was effective in facilitating team science, and how can we engage the next generation of team scientists? Ashley, maybe you can speak a little bit more towards that.
Yeah,
What worked and what
absolutely.
can we do?
I think something that was spoken about already that really resonated with me is creating these communities where folks can interact who are coming from different backgrounds. So I think conferences were mentioned, but I was fortunate to be funded on an NIH T32 earlier on in grad school. And as part of that program, we had folks from all sorts of different departments come and present twice a month. And so, I'm in, early human development, but I was hearing about bird feather formation or different marine biology projects, which was not only very inspirational and eye-opening, but it also helps you think about different ways to work with people or where there could be overlap that you couldn't see before. And so I'd say a continuation of really emphasizing interdisciplinary interactions early on in a career can help open up early career scientists' eyes to, hey, look at the power of working with people in spaces that maybe were not your first thought.
Yeah, thank you, Ash. I think that's something we've heard from nearly everyone, that engaging in team science and interdisciplinary science early in their career was really helped set them up for success. And I think as funders or the next generation of investigators or researchers, we can really think about continuing to engage earlier and earlier in the scientific career and provide these skills. And we also have to think about, what skills are relevant or most appropriate at each career stage. And I think that's some of the future work that we're working on now, is to understand, how teaming and team science varies across career stages. I don't want to take a lot of time, but there is some really good research from Guy Latriciano at George Washington University, like Nancy, that really talks about the motivations for collaboration, and they've looked at different career stages and roles and done a lot of work in this. It's really interesting to read. So Guy Latriciano, if anybody wants to read more about that. Thank you, Ashley. Dina, you want to talk a little bit more about, how we can promote effective team science and engage the next generation of team scientists? I know you have some thoughts here. Yeah.
Yeah, one of my favorite things is try to find topics which were overlooked and pay a little bit attention to them. And what I recently found is one of the variables. So I'm pretty sure that initial experience pretty much dictates how likely you will try to do something else. Imagine it's in a team science settings, right? It's not only if you will do it again, but how you will do it again. And I can see even from working with a team of principal investigators that after not really successful experience with the first U19 rounds, which was pretty much unpleasant, right? They don't want to go and do it again. When we're talking about early career scientists, isn't it exactly the same? Another thing I want to mention is this little investigation we did together with Farah and you about the Delphi consensus. One of the interesting conclusions we made was about tailoring the knowledge or expertise scientists early career scientists need in space and time. So originally we thought that let's figure out what are the topics which induce a lot of interest in the early career sciences. So we chose 11 actually, and they were pretty different. They were about the conflict resolution, U19 onboarding, about the data sharing, authorship and credit assignments, and exposure to broader range of expertise, and so on and so forth. So we wanted to see how people will make their choices. We got first data, and it was expectable. We got a lot of interest in the topic about exposure to broad range of expertise, communication issues, and mentorship. But when we started looking into demographics, for example, we took a portion of the respondents who were early into the U19, and their interest was mostly about the communication, collaboration, and so on and so forth. But in the later stages, people would choose topics like conflict resolution, onboarding, which was kind of pretty much late already, meaning that it's always appropriate time when the information should be delivered. And I have no idea how to solve this and how to make it like user-friendly and not that difficult for the entire community, but I think we should think about it more.
Yeah, thank you. I think, it was really interesting work that we did on that project. And I think, although it was grounded in just the U19 program, it probably will reflect a lot of trainees' experience. And we do have a lot of work to do to even just zoom in more on the early career stage and the temporal variations in that and how they impact both motivation and interests. I think it's really important. I do want to, just because you brought it up again, I think it's something I talked about. I just want to drop that article I was talking about with Dr. Litrikiano. You can look just a little bit, and he talks about kind of the things you talked about, Dina, as well. Put that in the chat to everyone who's in panelists. I don't know if I got one, but yeah. Okay, wonderful. I think how much we're doing okay on time. We got a couple minutes left. Yeah, and I think the key thing today is just all of you have identified really critical factors, facilitators, barriers to team science success grounded in your own experiences. And I think like I said, we're very early in even attempting to investigate or understand or develop even shared practices, certainly not best practices yet. And then this conversation is a critical step towards kind of identifying those topics and also understanding kind of what people are working on, so we can also work on those things together instead of independently. And like I said, make those more generalizable to everyone, just like Dina was mentioning. So I think with a couple minutes left, maybe I can just throw one question out to our trainees, our early career stage scientists. Where are you at on team science? Is it something you're going to engage on as you move through your career? How do you see your career moving forward with team science? Maybe we'll do it in reverse, and I can start with you, Dina, just very briefly. We've got 2 minutes.
With me?
Yeah, if you don't mind.
Okay, I want to study teams.
There we go. I have some good resources we can continue to discuss. Wonderful. Nancy, you're next on my screen. How do you see team science informing your future career?
I think being trained to look at health systems as complex adaptive systems. I like the notion of looking at team science as a complex adaptive system that includes scientists who are like interconnected together, interdependent on each other, with a clear role to each team member through a process team self-organization to generate and translate knowledge. And specifically because my area is translational science and implementation science. So I see myself to look at generating knowledge and scientific discoveries whenever they're ready to be translated. It definitely needs a team.
Yeah, I think you bring up an interesting point, which you've done a number of times in that we've known each other. But I think one of the things that Nancy has really impressed upon me over the time we've known each other is thinking about things at different scales and different levels. And you heard, Dina's talking about like, I want to study teams, and Nancy's talking about, I want to study systems. And like, this is one of the beauties of like team science is it takes all of us to really understand this, because it interacts at different levels and you can't just do it in isolation. So I love to hear these even different perspectives with an interest in team team science. All right, Mariella, and then we'll go to Ashley, and then we'll call it a day. How do you see team science in your future career?
Well, I'm going to echo a sentiment from physics, which is it's more than the sum of its parts when you do team science. And I like the research that comes out of these kinds of efforts, but I also really like the community because I have made a lot more friends being part of team science than I would by myself.
Yeah, we've had a great time putting together this event. A lot of us have worked together. Some of us had never worked together, and I hope that all of us will continue to work together in the future. And so I love, like you said, this conversation and building a community of practice is the critical foundation for this. All right, last, Ashley, Abel.
Yeah, I'll be brief. I absolutely see team science playing a critical part in my career after my PhD. I think within and beyond academia, team science plays a huge role, and we've seen, particularly over the last 4 years while I've been in graduate school, I've really seen this marriage of entrepreneurship and academia and translating some of these critical basic science discoveries we make in the lab into impactful translational therapeutics or other products that impact the public communities that we serve as scientists. So I think that team science from that perspective as well will be key, particularly in my field of women's reproductive health.
Yeah, thank you, Ashley. And I know we're at time. We'll finish this, but yeah, I mean, I too come from a entrepreneur and venture capital background, and I think that's like a whole other thing we didn't even get in today is like private-public partnerships and teaming there is certainly gets to what Nancy said, very complex systems. So there's definitely a lot of work to do, and I'm sure that you and I will continue to do that work. Okay, we're at 3:01. I don't want to take any more time, but I want to say first, thank you to our audience for participating and listening to this, and we encourage you to reach out to any of the panelists on the call. Thank you to our panelists, both our early career stage scientists providing their experience and perspective, as well as our NIH staff providing their perspective on developing programs here at NIH. If you have questions, reach out to us at NINDS Team Science. You can see us again on December 12th for the next NIH NINDS Team Science seminar. And of course, thank you to Anna and the Open Office, and we look forward to the next Open Stage webinar. So look forward to continuing the conversation with everyone. Thank you.
Thank you. Bye.